In this video, we're going to solve an equation using the quadratic formula. And the equation we're going to solve up here, the quantity r minus 2 times the quantity r plus 10 equals negative 9, is not exactly in the form that we need it in to just jump into the quadratic formula. It's important that you know the whole quadratic formula. Most of us memorize this part down here, the x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. But this first part is really important, and sometimes it's taken for granted, that this x equals business only works if ax squared plus bx plus c equals 0, and a does not equal 0 in this case, which I've made the a's red to, make them stand out, and the b's black and the c's purple. So a is representing the coefficient on the x squared term, the number in front of the x squared term. If a was 0, we wouldn't have an x squared term, and we wouldn't use the quadratic formula. And besides that, if we tried to, and we put a 0 in the equation, we'd end up with a 0 in the denominator, and that's undefined. If you try to divide by 0, the answer is undefined. So it is important that we have a quadratic equation. Now once we have the equation in this form, ax squared plus bx plus c equals 0, then we can take our values of a, b, and c and plug them into this formula. So the parts that are blue are always going to be there no matter what. And then whatever your a value is, you're going to plug it in two places, here and here. Your b value is going to get plugged in two places, here and here, and your c value only gets plugged in one place. But the first thing we have to do is make sure this is set equal to 0, which is not. It's equal to negative 9. So you might say, okay, well, I'll just add 9 over there. Alright, so let's say we add 9 to both sides. I guess I could show my work, huh? I'll write that. Plus 9 on this side, plus 9 on this side. So then we end up with r minus 2 times r plus 10 plus 9 equals 0. Alright, is that in the right form? Not quite, because we have it equal to 0, that's good, but it's not in this ax squared plus bx plus c equals 0. And we're using r's over here for our variables, so really we want it ar squared plus br plus c. So we need to have it in this form, and the way to get that is to multiply these two binomials together using FOIL, or distributing, however you want to think about it. So we have to take r times r times 10, then negative 2 times r, and negative 2 times 10. So let's go ahead and do that. So r times r is r squared. R times 10 is a positive 10r. Negative 2 times r is negative 2r. Negative 2 times 10 is a negative 20. And then we have this plus 9 sticking around here that we had, and we have equals 0. So now we want to combine our like terms. Let's get our r's together here, and then we also want to add our constant terms together there. That's very Christmassy. So we get r squared plus 8r minus 11 equals 0. Okay, so now we're in quadratic form here, and our a value is 1. Make that red. Our b value is 8, and our c value is negative 11. Let's make that purple, like I have it upstairs, up in the quadratic formula here. Okay, so now we're going to use this formula, and we're going to plug in 1 where the a's are, and 8 where the b's are, and negative 11 where the c is. So instead of x equals here, we get r equals, because that's our variable. The opposite of b, so negative 8 plus or minus the square root of 8 squared minus 4 times 1 times c, which is negative 11. Make sure I extend this out all over. This is another common mistake. People don't extend their fraction bar over the whole thing. Make sure you do that. 2 times a, which is 1. Alright, so now we got to simplify this thing. Let's start order of operations. Inside the square root, we would do the exponents first, so that would be 64. And the next thing we would do would be multiplication, so we can go ahead and do that here. Notice we want to think of this as a negative 4 times 1 times negative 11, which would give us a positive 44. Or you could write minus a negative 44, but then you're just going to have to change it to a plus anyway. And 2 times 1 is 2. and simplifying what's inside the square root, which is basically a grouping symbol if you're still thinking order of operations. That is 108 all over 2. Okay, so we got that part done. Now we're to the square root, and we need to simplify it. And the way to do that is to see if there are any perfect squares that go into 108. I'm thinking 4. So let's see. 108 divided by 4. 100 divided by 4 would be 25, so that'd be 27. So actually, that's 4 times 27, but 27 is 9 times 3. Let's double check. So 4 times 9 is 36 times 3. 30 times 3 is 90. 6 times 3 is 100, or 18, so that is 108. So there's 2 perfect squares that go in there, 4 and 9, or I guess 1 if you want to think 36 goes in there. Most of you wouldn't just look at 108 and go, oh, 36 goes in there. Some of you might. But, you know, start with 4 and see, and then 9. Check those first. Those are the most common ones, and 25. Okay, so we're going to take the square root of 4 and the square root of 9. So when we do that, this 4, when we take the square root of it, it's going to come out of the square root as a 2, because the square root of 4 is 2, and it's going to be right in front here, right in front of the square root. And the 9 is going to come out as a 3, because the square root of 9 is 3. So now we've got r equals -8 plus or minus. We got 2 that came out and a 3 that came out, and 2 times 3 is 6. So you times those together. 6 square root 3 all over 2. Which, you know, if you would have just thought of 4 times 9 is 36. Here, let me write this in green. Like if I would have went square root of 36 times 3, which is also 108, then the 36 comes out as a 6, which is what we have here. So, I mean, either way you want to do it, it's fine. Now, this fraction will actually reduce, but you want to be really careful here. You can't cancel this 2 with just the 6 or just the 8, because the whole thing's divided by 2, which brings me back to what I was saying earlier. Some people forget to divide the whole thing by 2, and they get lazy with their fraction bar. That catches up to you at this point, because then you might end up just canceling the 2 with the 6, which is wrong. The whole thing's divided by 2, so every term has to be divided by 2. And I can cancel a 2 out of the 8 and the 6 and the 2. Now some instructors might want you to actually factor the numerator and take a 2 out of the numerator, greatest common factor, like this. Oops. Oh yeah, that's right. Okay. And then it's easy to see that 2 out there. See, if I distributed this 2 back in, I'd end up with what I started with here, taking out the greatest common factor. Now it's a little safer canceling these 2's, and end up with my answer. R equals -4 plus or minus 3 square root 3. Alright, I hope that helped. I'd like to give you a quick example that maybe you could try. You could pause the video and give it a try. I'm going to have to erase something here to write it in. How about if I just erase this? Hopefully you've got that written down. Let me erase this up here. Okay, so here's a problem for you to try if you want to give it a try. So we're going to solve the quantity 2x minus 4 times the quantity x plus 5 equals 3. So if you want to pause the video and give that a try, I will write the answer up here in a second. I'm not going to go through how to solve it because I don't have time in this video, but hopefully you'll get a chance to practice and get the right answer. Alright, so here's the answer you should have came up with. X equals -3 plus or minus the square root of 55 over 2. Hope you got that right. Hope this video helped. If you didn't, drop me a message and I can help you figure out where you went wrong.